Hello, this is Idea Nexus, a YouTube channel about computer science and gaming, sometimes just about computer science, sometimes just about gaming. In my last video, I was talking about computational artifacts you can create without any computers, and these are ways of arranging numbers on paper to explore the patterns within them and the relationship. So, for example, over here on the right, we have Ulam's spiral, where a mathematician wrote out numbers into a spiral onto a grid, creating squares of increasing size to create this kind of quadratic diagram where the exponents line up along these two branches. The even numbers line up along diagonals, and the odd numbers line up along diagonals, which creates these diagonals where primes are much more likely to be found, and it creates an interesting pattern. And we can see a pattern in primes where we wouldn't normally think we could see one. Over here, another example is the number mandala, where we've taken the numbers 1 through 12, written them out in a circle of increasing circles, and that sorts the even numbers along these green branches. The factors of 3 are sorted along the red branches, and this confines the prime numbers to these 4 branches, and I've highlighted the primes here, so we know that we can find the primes here. Now, as interesting as these artifacts are, and as fun as they are to make, they are very time consuming to make. For example, the Ulam spiral it took me about an hour to make a 22 column Ulam spiral, where a computer can make a 300 column Ulam spiral in just a few milliseconds. So computers allow us, while these handwritten diagrams allow us to explore patterns, computers allow us to explore and experiment with these patterns much more quickly and much more rapidly. Computers encourage experimentation and exploration of patterns. And over here with the number mandala, I decided one day I wanted to write out a number mandala on an HTML canvas, and that's the result here. So you can see we've got the different branches, we've got the primes highlighted, so we know where our primes are combined to. And I built this in an afternoon. It was a lot of fun to build, and I was proud of it for maybe half an hour, and I got bored with it very quickly, and therefore decided to add this control panel where I can start changing the different variables that went into making this. So for example, I want to connect the factors of 5. So we draw a line connecting the factors of 5. Well, that's an interesting pattern. We've created these overlapping triangles, and it kind of creates an interesting pattern, but also a bit of chaos. Well, what if we connect the 6s? Well, that's very boring, and it makes sense that these 6s would be connected along there. Same thing if we connect the 12s, we get one line up along there. And if we connect the 11s, it's the same circle as the 12, but one behind, and so it creates this kind of nice spiral effect. And this allows us to very quickly generate different patterns using different variables to see what kind of patterns just come out. We don't have to do a lot of thinking about it. We don't have to do a lot of drawing and coloring and creating. So maybe how about instead of 12 ticks, I want to see what happens if we do 11 ticks connecting the 5s, and it creates these kind of interesting boxes. Now, programming this, I wanted to talk for a moment about programming this. This is available online. It's free. Programming this involved a lot of what we call in computer science decomposition, and decomposition is just a really valuable skill to have. It's in any situation. In order to draw this initial diagram, I had to. If you went online and said, "Well, how do I draw a number mandala?" You're not going to find any answers. What you have to do instead is you have to break this big problem down into a lot of little problems. So the first problem was, well, how do I draw a number on an HTML canvas? Okay, well now that was easy. How do I create a circle of numbers 1 through 12? Well, it turns out that's a clock face. So we draw a clock face, and then Now I want to create bigger and bigger circles. Well, we just increase the radius here. And by solving each of these individual problems, each problem, thinking of it as a tree, if I solve each tree of a problem, we end up creating this forest of a much more beautiful and much more an application that is much more than the sum of its parts. For example, here is a prime number. I needed to know how to check if something is prime, and I found a lot of beautiful algorithms on how to generate primes. And so we have this forest of an application, and we can now very quickly explore a lot of different patterns. And one of my favorites is I'll set it to randomized, and there's this render preset, and I'll just click here, and it's a fun game to try and play, is maybe to guess, well, what are the variables that went into making this diagram? And it's not as difficult as you might think, but you don't even have to do that. Sometimes you can just sit back and appreciate the emergent patterns that come out and the beauty of exploring mathematics. If you like this application, it's on GitHub. Feel free to grab it. If you think to yourself, I would love to see what other kinds of variables people would love to add to this dashboard. Do whatever you want. See what other kinds of patterns you can create. And that is the power of computers, the ability to explore and experiment in ways that we couldn't before, because the computer empowers us by doing so much of the thinking for us. Thank you so much for tuning in, and I'll see you again soon. Oops. And I'm out now. Bye.